Welcome to an introduction to quadratic functions. A quadratic function is a function which can be written in the following form. F of x equals ax squared plus bx plus c, where a cannot be 0. Ax squared is known as the first term, and a is called the coefficient of x squared or the coefficient of the first term. Bx is considered the second term, where b is the coefficient in front of x, and c is the third term. It's also known as the constant since it is not associated with the variable. Every quadratic function has an x squared term. Let's take a look at some examples of functions that are quadratic. Functions like f of x equals 2x squared plus 3x plus 5, g of x equals negative x squared plus 4x, h of x is equal to 1/3 x squared plus 1/5 x. All of those functions have an x squared, and that is the highest power on the variable. They are all quadratic functions. Now let's contrast that with functions that are not quadratic. The functions f of x equals square root of x is not quadratic since quadratic functions do not involve square roots. The function g of x equals negative 3 over x minus 1 is not quadratic since there is an x in the denominator of this fraction. The graphs of all quadratic functions are related to its basic function, which is just f of x equals x squared. This is a parabola whose vertex is at 0, 0 and opens up. It has a domain of all real numbers or negative infinity to infinity and a range from 0 to infinity. While the graphs of different quadratic functions will look slightly different, they will all have the same basic shape. Let's take a look at some of the characteristics of the quadratic function. Every quadratic function has a U-shaped graph known as a parabola. The parabola will open up if the coefficient a is greater than 0, and it will open down if the coefficient a is less than 0. C, the constant on the end of the quadratic function, is known as the vertical intercept. You can write that as a coordinate point by writing 0c. So if you look at this graph here, this parabola opens upward. That means without even knowing the formula for this function, we know that the value of the coefficient in front of x squared a will be greater than 0. This parabola opens down, so without knowing anything about the parabola, we know that the coefficient a, which would be in front of x squared, is going to be negative or less than 0. Let's take a look at a few examples. Let's use the function f of x equals x squared minus 2x plus 3 for this first example. Let's start by identifying the coefficients a, b, and c. A is the coefficient of x squared. In this example, a is equal to 1. B is the coefficient of x, so in this case, b is equal to negative 2. And c is the constant term on the end, so for this function, c is equal to 3. Now let's use these coefficients to determine which direction does the parabola open. To identify the direction of the parabola, we use the coefficient of a. Since a is 1, which is greater than or 0, that tells us that this parabola will open up. Now let's find the vertical intercept. The vertical intercept is associated with the constant term c. For this function, we know c is equal to 3. That means that this parabola will have a vertical intercept at 0, 3. Let's verify this information by graphing the function using Desmos. Open the website desmos.com. You can find a link to Desmos in the description of this video. To open the graphing calculator, press the button toward the top of the screen, or from the Math Tools menu, select Graphing Calculator. When the graphing calculator first opens, you should be looking at a blank graph. Go over to the first cell on the left-hand side and enter the function. You can enter the function using the keypad down in the bottom left-hand corner. If you need to toggle between the numeric keypad and the alphabet, just click on the button in the lower left-hand side that allows you to toggle between alphabet and numeric. Or if you're using a computer, you can just simply type the function in using your keyboard. So I'll type f of x equals x squared minus 2x plus 3. If you press and hold on the left-hand side, you can change both the thickness and the color of the graph. Earlier we said because the leading coefficient a was 1, which is greater than 0 or positive, this parabola was going to open up, and indeed this parabola does open upward. We also said that since the constant term c was 3, it had a vertical intercept at 3. We can verify this information using Desmos by simply clicking on the vertical intercept on our graph. When I click to reveal the coordinates, I see the vertical intercept is the coordinate point 0, 3. Let's go back and take a look at our second example. For our second example, we'll use the function f of x is equal to negative 4x squared plus 2. As always, we need to start by identifying the coefficients a, b, and c. A is the coefficient of x squared, so in this case, a is equal to negative 4. B is the coefficient of the second term, x. However, this function doesn't have an x term. That actually tells us that the coefficient b is equal to 0, because 0 times x, which would be 0, but we don't really write plus 0. C is the constant term, and so for this function, c is equal to 2. Now let's use our coefficients to answer the following questions. Which direction does this parabola open? To identify the direction the parabola opens, we need to use the coefficient of x squared, which is a. In this case, a is negative 4. Since negative 4 is less than 0, this tells us that this parabola will open downward. Now let's find the vertical intercept. To find the vertical intercept, we need to use the constant term c. In this case, c is 2, so this parabola should have a vertical intercept at 0, 2. Now let's graph the function using Desmos to verify this information is correct. Returning back to our Desmos graphs, there's a couple things you could do. You could go up and just edit your first function. You could click on the 3 lines in the upper left-hand corner and then open a new blank graph. Or you could temporarily toggle off the graph of our first function, click into the second cell, and then add your new function to the second cell. I'll do that. So I've entered the second function, f of x equals negative 4x squared plus 2 into the second cell, and I've changed the color to blue. Earlier we said that because the value of the leading coefficient a was negative 4, this parabola would open downward, and we can see this parabola does indeed open in a downward fashion. We also said since the constant term c was 2, that the vertical intercept would be at the coordinate 0, 2. Let's verify this by going over to the graph of our function, clicking on the vertical intercept of our graph to reveal the coordinates. We see that it is indeed at 0, 2. You can find a link to these graphs in the description below. That's it for this video. Thanks for watching.